Software tool for economic analysis of grid-connected solar PV system with battery energy storage for domestic and bulk customers. Global temperature has risen drastically after Industrial Revolution, causing harmful climate change, the rise of sea level and melting of glaciers. This has affected over ecological, social and economic aspects of the whole world. According to NASA, Earth's temperature has risen by 0.08 degrees Celsius per decade since 1880, but the rate of warming since 1981 is more than twice of that. Global temperature is projected to rise by about 1.5 degrees Celsius and by 2050 and 2 to 4 degrees Celsius by 2100. The main reason for rise in global temperature is carbon dioxide emission from burning of fossil fuel. In 2019, nearly 70% of world energy demand is met by burning fossil fuels. 64% of electricity generation came from fossil fuel sources. To reduce the carbon dioxide and other harmful gas emission, we need to reduce the dependency of hydrocarbon fossil fuels. The world has paid their attention towards renewable energy sources such as solar, wind, geothermal, tidal and biomass. The public and the policymakers are taking steps for the transition into renewable energy sources to reduce the global warming. In the renewable energy drive, solar and wind energy can be considered as leading candidates. Out of them, solar PV technology is more popular due to its residential and utility scale usage. In solar PV technology, photovoltaic cells convert the photon energy of sunlight into electricity. In concentrated solar PV systems, the heat energy of the sun is used to produce electricity. In the solar PV technology, the prices of the solar panels has reduced and efficiency has increased over the last decade. The ground-mounted solar plants can produce more energy than rooftop solar PV system by placing correct orientation and tracking methods. Rooftop solar PV system is a photovoltaic system that has its electricity generating solar panels mounted on the rooftop of a residential or commercial building or structure. The DC electricity generated is converted into AC electricity by an inverter. The converted electricity can be used to directly feed loads, export to the utility grid or store in a battery energy storage. Let's discuss about the perks of moving into rooftop solar PV system with energy storage system. You can directly reduce the emission of carbon dioxide as you reduce the load on fossil fuel plants. You can be independent from grid. You can avoid unscheduled interruptions, load sheddings and blackouts. If you are using a time of usage tariff, you can avoid expensive rates at peak time. On top of that, you can get an income or reduction on your monthly electricity bill on exporting energy to the grid. When an individual or a business decides to move on to a rooftop solar PV system with energy storage, there are few doubts to be answered. The investment, will it be worth? Do I get the return I expected in a given period? What is the optimal size of the system that should I get according to my electricity demand? What kind of connection should I get? What will be my optimal sizing of equipment to feed my load and get the return I expected? In our final year project, the final output that we offer is a software tool that a client can decide all of the mentioned doubts in a simple and quick way. Currently in Sri Lanka, there's no such tool to analyze the techno and economic features of a solar PV system with energy storage. The algorithm consists of both technical and economic calculations. At first, the technical parameters such as location, price of the components, rooftop area, load profile and connection type are entered by the user. Then the period during which battery discharging should occur is determined by the user as well. Based on the load during that interval, which can be calculated from the load profile, battery sizing is done considering other constraints such as charging and discharging efficiency, maximum depth of discharge and maximum state of charge. The PV system is sized based on the inputs mentioned above. The loop runs until maximum possible PV size is calculated. Here, the minimum size is determined as to deliver the power to charge the battery, and the maximum size determined when the whole roof is covered by the solar PV modules. For each combination, the benefit and cost calculation are conducted based on the export to the grid and net present value analysis for 20 years is calculated as well. considering net accounting and net plus schemes that are available in Sri Lanka. The system combination with the highest net present value is displayed as the output. This is the user-friendly software tool. Let us see how the software tool works. As mentioned in the algorithm, the software tool takes system parameters, load profile, geological inputs, and economic parameters as inputs. The losses such as mismatch losses, wiring losses, temperature derating, panel orientation losses are assumed as the values shown in the tool. However, user can change them accordingly if he wishes. The battery discharging time is selected. Let us see how the software works using an example case, which is a case study carried out at the Department of Town and Country Planning at University of Moratuwa as a part of our project. The DC rating of the selected PV module is 500 watts. The module area and module efficiency are 2.54 square meters and 16%, which can be determined from the datasheet of the module. Next, the tariff is selected. Then the load profile is added to the software tool. For the geological inputs, district location of the building is selected as Colombo. The rooftop area is calculated using Google Earth and the value is 316.65 square meters. The current price of the 500 watts PV module is 80,000 rupees and the discount rate is considered as 9% for the net present value analysis. The losses are assumed to be the default values shown in the software tool. As it can be seen in the visualized load profile, the need for battery discharging can be assumed to be between 11 am and 1 pm. Based on these inputs, the NPV analysis is done and the optimal PV and battery size are shown. The analysis plot shows although the maximum possible system size is 65 kilowatts, the most economical PV system size is 45.5 kilowatts. Additionally, the user can opt for any other configuration using the plots. This user-friendly software will help the user to figure out the most economically beneficial system without needing much knowledge on this matter.